What is a heat sink and cooling system design? Imagine a tiny device working tirelessly inside your computer or a mechanical system, generating heat with every task it performs. Without a way to manage that heat, the device could overheat and stop working. That's where a heat sink comes into play. It is a passive component designed to transfer heat away from heat-producing parts to keep everything running smoothly. Think of it as a heat's escape route, helping to prevent overheating and ensuring devices stay within safe temperature limits. A heat sink is made to absorb heat from a source like a computer processor or power transistor. It does this through conduction, which is the transfer of heat directly from the hot device into the cooler material of the heat sink. Once the heat is inside the heat sink, it spreads across its structure, which is often made of materials with high thermal conductivity like copper or aluminum. These materials are chosen because they quickly transfer heat away from the source. Most heat sinks have a flat base that touches the heat source directly. Attached to this base are multiple fins or pins that extend outward. These fins increase the surface area of the heat sink, making it easier for heat to escape into the surrounding air or liquid coolant. The larger the surface area, the more efficient the heat transfer. The heat then leaves the heat sink mainly through convection, which is the movement of heat into the air or liquid, and to a lesser extent, through radiation. Heat sinks can work passively, relying on natural convection where warm air rises and cooler air moves in. They can also be active, where fans or pumps force air or liquid to flow faster over the fins, speeding up heat removal. This is especially useful in high-power electronic devices or mechanical systems that generate a lot of heat. In practical applications, designing a good heat sink involves calculating how much heat it needs to handle, called the thermal load. Engineers consider the thermal resistance, which measures how well the heat sink resists heat flow. They also pay attention to the size, shape, and spacing of fins, as well as the material used. Proper thermal interface materials like thermal paste are applied between the heat source and the heat sink to fill tiny gaps and improve heat transfer. In essence, a heat sink is a carefully designed component that acts as a heat's escape hatch. It pulls heat away from sensitive parts, spreads it out, and then releases it into the environment. This process keeps devices cool, prevents damage, and keeps everything working reliably. Whether in electronics or mechanical systems, heat sinks are key to managing heat and maintaining optimal performance.